Hey there, this is the video looking at kinematics, so at the start of the Mechanics 2 chapter. The only difference really between this and Mechanics 1 is in 2 dimensions. Okay, so just look at 2 quick examples. Here we have particle projected at this speed, angle of 30 to the horizontal, as in my lovely diagram here. Find the greatest height, so that's this height here. The time of flight, so the time it takes to get from here to the end, and the range. The range is horizontal distance. Okay, I'm going to use v squared u squared plus 2as, 2 greatest heights. I know that at greatest height vertically, v is 0. I should really have said vertically there. Well, I'm saying up, I suppose. Anyway, u is the component vertically, that's 10 cos, so vertically must be 10 sine. So that's 10 sine 30 squared minus 2 times 9.8 times h, the height, greatest height. So minus, because I've said I'm taking it upwards and gravity acts downwards. Okay, rearranging that, I get the greatest height h as 1.28 meters. I then use v equals u plus at, again up to greatest height. What I'm doing here is I'm finding, v is 0, again still at greatest height, I'm finding the time it takes to get to the greatest height, and in this case, because it starts and ends at the same level, I know that the time to get to here is the same as time to get from here back down, so I simply double it to get the time of flight. There are other things I could do. I could have used s is ut plus half at squared vertically and put s as 0, but I just like doing this. Okay, here to get the range, I use s is ut plus half at squared horizontally, and that is equal to 10 cos 30, because 10 cos 30 is the component here horizontally, times 1.02, the time it takes to get to there, and this I ignore because there's no acceleration horizontally, or we'd all spend our life slammed up against the wall. Let's look at the next one. Particle here projected with velocity, oh no, vectors I and j. The reason I've done this question is because a lot of people get very confused on these, and they really needn't. It's just componentized it already for us. So 5u going along and 4u going up. That's all it's telling us. Okay, I'm going to use s is ut plus half at squared downwards. I really should say from point A to point B. So the displacement downwards is 8, because that's 20 and that's 12. I've got minus 4u here. Now you're thinking, why have you got minus 4u? Well, that's up, we're taking down, so that's minus 4u. And then 4.9 is half of a times my time squared. So I rearrange all of this malarkey. This goes over here, both negative, divide by 16. I get u is 4.4. Okay, v equals u plus at upwards to b. So I've got, I could have used up, could have used down, doesn't really matter, does it? It's just going to be reversed. So I've got 4u, the component acting up, minus 9.8 times 4, the time of 4. So I rearrange this, I get v as minus 21.6, which is actually the same as, oh, who put that there? Quick, scrub it out. Where's my pen? I don't know which one of these two it will be, actually. It will be one of these two. I've just made an error in transposition across from there to there. Okay, let's assume it's the 21.6, and that should be a 1. Right, v is u plus at across to b, horizontally. V is 5 times 4.4, which is 22 meters per second. That 5 times 4.4 is just this u bit. There's no acceleration horizontally. Okay, so it's 5u horizontally. And it remains the same horizontal velocity all the way through. My speed is simply the 2 components of my velocity squared and square rooted. Okay, silly error here, but apart from that, it's all good. See you next time.